Welcome to this extended episode of AI Frontiers, where we embark on an in-depth exploration of the cutting-edge world of computational linguistics. Today, we're diving into a treasure trove of research from the arXiv preprint server, specifically focusing on papers categorized under cs.CL, which stands for Computation and Language. This category is a goldmine of innovations in natural language processing, machine translation, and various other language technologies that are shaping the future of how we interact with machines. Unlocking Language. Frontiers in Computational Linguistics. Synthesizing 146 papers published on the 26th of May 2025. In this presentation, we will dive into the vibrant world of computation and language. Key themes and groundbreaking findings from recent research will be discovered. Various methodologies and their implications for the future will be explored. Additionally, seminal papers that are shaping the field will be highlighted. Computation and language is a vibrant intersection of computational methods and linguistic studies. This field enables machines to understand, interpret, and generate text and speech in a meaningful and contextually appropriate manner. Applications include voice assistants like Siri or Alexa, translation tools like Google Translate, and automated content generation. The significance of this field lies in its potential to revolutionize human-computer interaction, making machines more intuitive and responsive to our needs. One dominant theme in recent research is the adaptation of language models to low-resource languages and specific domains. For instance, a study by Odunayo Ogundepo et al. 2025 explores strategies to adapt models to African languages, which are often underrepresented in training data. This work is crucial for making language technologies more inclusive and accessible to a global audience. Enhancing global accessibility of language technologies. Another prominent theme is the use of language models for specialized tasks. A paper by Gulfaro Azam et al. 2025 evaluates how well general-purpose models perform in transliteration tasks compared to specialized models, providing insights into the versatility of foundational language models. Foundational models' versatility with minimal overhead. Misinformation and bias in language models are also hot topics. Akram Elbouanani et al. 2025 propose a new approach to analyze political biases in language models, highlighting the need for more robust bias analysis methods. Ensuring fairness and ethical alignment in AI. A particularly intriguing theme is the exploration of consciousness and ethical alignment in language models. Sirui Chen et al. 2025 discuss the potential for language models to exhibit consciousness and the associated risks, delving into the philosophical and ethical implications of advanced AI systems. Balancing innovation with ethical responsibility. Several groundbreaking results stand out for their potential impact on the field. One significant finding is that general-purpose language models can outperform specialized ones in certain tasks. Gulfaro Azam et al. 2025 demonstrated that models like GPT-4o, when fine-tuned, can excel in transliteration tasks, even surpassing specialized models like IndexLit. This suggests that foundational models can be highly versatile with minimal overhead. Additionally, the introduction of the chain of unconscious thought (CoUT) paradigm by Ruohan Gong et al. 2025 improves token efficiency in large reasoning models by mimicking human unconscious thought, reducing token usage by 47.62% while maintaining accuracy. Latency-aware test time scaling, as demonstrated by Zili Wang et al. 2025, significantly improves the performance of language models in time-sensitive scenarios, enabling a 32B model to reach high accuracy within a minute. Multi-agent collaboration is also emerging as a powerful technique. Yichun Zhang et al. 2025 presented The Avengers, a framework that leverages the collective intelligence of smaller language models to challenge proprietary giants. This approach outperformed GPT-4.1 on several datasets, highlighting the potential of collaborative smaller models. Several common techniques emerged from the papers, each with its strengths and limitations. Fine-tuning and adaptation are widely used to tailor large language models to specific tasks or domains. This method is effective but can be computationally intensive and require large amounts of labeled data. Reinforcement learning is another powerful technique. It can enhance model performance by guiding reasoning in language models. However, it requires careful design of reward functions and can be complex to implement. Meta-learning offers a unique perspective on understanding and improving the reasoning capabilities of language models. This method conceptualizes reasoning trajectories as pseudo-gradient descent updates, providing a meta-learning perspective on model training. While powerful, it can be theoretically dense and requires a deep understanding of optimization techniques. Hybrid neural symbolic retrieval combines the strengths of neural and symbolic retrieval methods to improve the accuracy of question-answering tasks. This hybrid approach is effective but requires sophisticated integration of different paradigms. Multitask reinforcement learning can enhance model performance by targeting multiple sub-skills simultaneously. However, it requires careful design of reward mechanisms to balance different tasks. Let's take a deeper look at 3 seminal papers from this collection. The first paper is Beyond Specialization: Benchmarking LLMs for Transliteration of Indian Languages by Gulfaro Azam et al., 2025. The objective of this paper is to evaluate the performance of prominent large language models, LLMs, in the task of transliteration for Indian languages. The study seeks to understand whether general-purpose models can match or even surpass the performance of specialized models like IndexLit. To achieve this, the researchers conducted systematic evaluations using standard benchmarks like Dakshina and Aksharantar datasets. They assessed performance via TOP1 accuracy and character error rate, comparing models such as GPT-4o, GPT-4.5, GPT-4.1, Gemma 3-27 and Mistral-Large against IndexLit. The findings revealed that GPT family models generally outperform other LLMs and IndexLit for most instances. Fine-tuning GPT-4o further improved performance on specific languages. The study also included an extensive error analysis and robustness testing under noisy conditions, highlighting the strengths of LLMs in specialized applications. This research underscores the potential of foundational models to excel in specialized tasks with minimal overhead. It suggests that general-purpose models can be highly versatile and effective, reducing the need for specialized models in certain applications. The second paper is Improving Multilingual Math Reasoning for African Languages by Odunayo Ogundepo et al., 2025. This study focuses on adapting large language models to low-resource languages, particularly African languages, for mathematical reasoning tasks. The goal is to identify the most effective strategies for extending existing LLMs to these languages. The researchers conducted extensive experiments and ablation studies to evaluate different combinations of data types, translated versus synthetically generated, training stages, pre-training versus post-training, and other model adaptation configurations. They used the Llama 3.1 model family as their base model. The experiments revealed that multi-stage pre-training and post-training paradigms can significantly enhance the performance of LLMs in low-resource contexts. The study also highlighted the importance of using translated data over synthetically generated data for better adaptation. This work provides valuable insights into adapting language models to low-resource languages, a critical area for advancing inclusivity in AI. It offers a roadmap for improving the performance of LLMs in underrepresented languages, which is essential for global AI applications. The third paper is Deciphering Trajectory-Aided LLM Reasoning: An Optimization Perspective, by Junan Liu et al., 2025. This paper aims to understand the reasoning capabilities of large language models, LLMs, through the lens of meta-learning. The goal is to conceptualize reasoning trajectories as pseudo-gradient descent updates to the model's parameters. To achieve this, the researchers formalized the training process for reasoning tasks as a meta-learning setup, with each question treated as an individual task. Reasoning trajectories served as the inner loop optimization for adapting model parameters. The study included extensive empirical evaluations to explore the connection between LLM reasoning and meta-learning. The future of computation and language is bright but requires continued innovation and interdisciplinary collaboration. As language models become more integrated into our daily lives, it's crucial to ensure they are fair, unbiased, and efficient. The research we've discussed today provides a solid foundation for addressing these challenges and paving the way for even more advanced and inclusive language technologies. One key area is the need for more robust evaluation frameworks. As language models become more sophisticated, it's essential to develop benchmarks that can accurately assess their performance in real-world scenarios. This includes evaluating models on a diverse range of tasks and languages, as well as under different conditions such as noise and low-resource settings. Another critical challenge is addressing biases and ensuring ethical alignment. As language models become more integrated into society, it's crucial to ensure they do not perpetuate or amplify existing biases. This requires developing more robust bias analysis methods and ensuring that models are trained on diverse and representative datasets. Additionally, there's a need to explore the philosophical and ethical implications of advanced AI systems, such as the potential for language models to exhibit consciousness.